Oh, I thought okay, I'm sorry.
You did
Okay.
start it.
I'll have to start, I will just start it from today. Okay. All right, so here it shows the same material or the same numbers or the same whatever, but the second one looks more steep than the first one, all because of my manipulation of the y-axis. So that's something I could do to make something look more steeper or something look like a more drastic change. Okay, why is it? Okay. The graph in part A appears to show a greater increase than the part B because we're using a different scale. See, same scale, 95 to 100. But here I've got 20, 40, 60, 80. It shows a different. See, it can be manipulated. Consider a claim that if you invest $1, by next year you will have $2. This type of claim is sometimes misrepresented. Somebody tell me why this is misrepresented. Everybody knows that 2 is double 1, but why is it misrepresented?
Because the box is way bigger than double.
Exactly. I could actually take, hold on a second, oops. And I think that's what they're going to do with it, but I'm going to do something. I'm going to take my handy dandy snipping tool. Mr. Robinson ever show up?
No. No, sir.
He's probably drunk. That's a joke. It's a joke. Ha ha ha. Okay, take my snipping tool, and I'm going to go back here. And I'm going to take my snipping tool, and I'm going to pull that out. And I'm going to save that. Or I can copy it. But I'm just going to go in here. No, I can't. I don't think I can do this. Let me try something else. Can I actually snip this out? And okay, I'm talking to myself, just ignore me, please. Snip. I'm going to try one more time, and I'm going to try to copy it. Things I do for y'all.
I know.
Well, the snipping tool went away. Where'd it go? Oh, come on. There. I'll try this one more time. I don't think I can do it unless I copy it. It'll let me copy it. I can do it. Nope. It's not do it. Oh well, I tried. Because when I go to print or go to the slideshow, it's not going to let me. I'm not going to be able to nope, not going to let me. When I'm on transparency, I can't bring in stuff. Oh well. Nope. Oh well, if you was to take this, I'll tell you what I can do though. I can take this and make me a square like this. And now I can copy that. No. But anyway, I'll do it this way then. That square right there, if you take this square and put it on top, that's only double. This thing is about 4 times, this green square is about 4 times as big as what? The yellow square. So it's a misrepresentation. And those are the things. Now I will give you a couple of these on the test. So make sure you understand what I'm saying here. I'll shut up, keep going. And I think that's what they're going to right here. Actually, it's more than 4 times. It's probably 8 times. But This is the number one test question I would give you. You might want to write it down. You don't have to write it down per words, but anytime you have a graph, especially a pie graph, all the percentages should equal what?
100.
100, just like, and in probability and statistics, in probability the answer, it adds up to equal 1. But in percentages, they have to equal 100. Just like the question I asked you on your test. I asked you, what is the weights of the test in Hubert's class? And there's one that says 30, 30, 30, and then there's one that says 20, 10, 70 or something like that. Only one of them is equal to 100. The other one is not. All graphs, all percentage graphs should equal 100. This one does not, because heck, you have 50 right there and 42 right here. This over here has to equal 50, and there's 30, there's 37 and 24, there's 50, almost 61 right there. So this does not equal 100. It equals way over 100. That is a good test question. You will see that on the test. Okay, so that ends that. That was important. Those 2 or 3 slides was very important, like I said, because, let me get the other one pulled up, because you need to see it. Okay, I don't know which one. I guess this is 2. What is a frequency distribution? A frequency distribution is a table. Okay? A frequency distribution is a table. If I was to give you a table and I say, how many blondes, brunettes, and redheads we got in the class? Blondes, brunettes, and redheads. And I told you 4, 8, and 2. That is a frequency distribution. Now, what are these? Well, these are what we call qualitative data. What's qualitative data?
Numbers. Oh, no, that's the items.
It's like
The
a
words.
characteristic. I don't know how to spell characteristic, so is it C-A-R-A-C-T, characteristic? I'll just put all my letters together so you can't see it. Characteristic, all right? It's a characteristic, meaning blonde, brunettes, or redheads, versus a class, and this is called a category. Make sure you make that distinction. Category. A category is when it's qualitative, meaning that blonde, brunettes, redheads, green eyes, blue eyes, brown eyes, okay, and other. Those are all characteristics. Those are all categories. If I was to give you a quantitative, I'm sorry, not X and Y, that's algebra. Sorry, I'm used to writing X and Y all the time. Then I would do classes. And that is quantitative, and classes basically are numerical. Numerical meaning average age, 10 to 19, 20 to 29, 30 to 39, and then I would put 2, 4, 6. Okay? So there's 2 types of frequency distributions. There is the qualitative categorical frequency distribution, and then there's the quantitative numerical distribution. Of course, in probability statistics, most of the time you're dealing with this one. Okay? Now, if you was to just take a survey, this would be like in a survey, but it wouldn't be statistical because you can't calculate blondes, brunettes, and redheads. There's no numerical data there, so you can't calculate with that. Now, you could assign a number to blondes. Maybe blondes are 0, brunettes are 1, and redheads are 3. But that would be worthless because there's no weight to that number assigned for 0, 1, and 2. There's no weight. There's no meaning to it. Okay? Always remember, quantitative data means that the number is calculatable. It is numerical. What if I put down your Social Security numbers in a table? Would that be numerical? Would that be quantitative, or would that be qualitative? It would be qualitative. But they're numbers, Hubert. Yeah, but do they mean anything? They mean absolutely nothing numerically. All they are identification numbers. If you take one Social Security number and add it to the other one, it does not give you a meaningful answer. Okay? But as an identity or as a characteristic, it identifies you as from somebody different from somebody else. Okay? And that's the difference between a category and a class. So make sure you understand the difference between a category and a class. Okay? Here is a bunch of dadgum numbers. Okay? What they're going to do is we're going to put them in a class. 0, 1, 2, 3, 4, 5, class. 0, 1, 2, 3, 4, 5, 6. And I'm just going to, and this is what they're going to do on the next page. Here's your frequency. Zeros. 1, 2, 3, 4, 5, 6, 7, 8, 9. And then I go, okay, how many zeros do I have? 1, 2, 3, 4, 5, 6, 7, 8. I've got 8 zeros. And how many ones do I have? Well, there's 8, 9, 10, 11. I have 11 ones. And then 2s. Well, there's 1, 2, let's just say 2, 4, 6, 8, 10, 12, 14, 16, 18. And how many 3s do I have? Well, 1, 2, 3. We know that's 8. That's 11. 4. 1, 2, 3, 4, 5, 6. 5. 1, 2, 3, 4. 6, 2. 7, 1. 8, 2, and 1. Now, what do you do if you add, I call this the head count. That's with your pinky down. If you hold your pinky up, it's called the frequency. So, frequency is when you hold your pinky up. Okay? And there will be some times that a test or a homework question will ask you, what is the summation of the frequency? And the summation of the frequency is called N. When you add up all those numbers, that's the summation of the frequency, which is equal to N. N is always your biggest number. Write that down, highlight it, put a star beside it, put a circle around it. N is always your biggest number. It is always the total. So the total here is going to be 19, 20, let's see. There's 19. That's 20. There's 10, so that's 30. 40, 51, 52, 53, 54. I don't know. It looks like N is equal to 54. Somebody check me. Let's check. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 64. I must have dropped a 10 somewhere. So if I add up all of my numbers on the head count, I will get the summation of the frequency. Or
can we move you with that little arrow beside you? Is that how you move it?
What'd you say?
How do we move you? Like
Oh, I'm sorry. If you look to the right of me, there's a little white arrow. If you click on that white arrow, it will make the box bigger, and then you can slide it over. Y'all have two monitors, don't you?
No, we just have one big.
Okay, so you need to just make it a little bit bigger.
Okay, we're good. You always write on that side, and that's where you always are, so we just moved you over there.
Oh, what side do I write on?
The right side.
Oh, is that where you, okay. Because I'm looking reverse in the mirror, in the window back there, I'm on the right side, but that means I'm on the left side. The door back there in your room, I can see the reflection. Okay, so the summation, so what do you need to gather from this? First of all, I can't stand writing in red. It gives me the heebie-jeebies. Okay, N is always your biggest number, and in this case, it's 64. It's also called the summation of a frequency. And that big E, that big funky-looking E, is capital sigma. That right there is sigma. And it means add all the numbers up. That's what it means. Add all the numbers up. So when you get that sigma, you're going to see it later. That means add them all up. And if you add up the frequency, that's going to give you N. N is always your biggest number. Okay? If I say how many people in a class are blondes, brunettes, and redheads, and there's 30 people in the class, then N is equal to 30. It's usually your denominator. If you're trying to find a relative frequency, it's going to be your denominator. So in this case, 64 would be my denominator because it's N.
Gotcha.
And think of it as test scores. You remember how you used to find out your average when you were in school? You still do, but I'm just using, when you were coming up through high school and you want to know what you had in history, what would you do? You add up all your test scores and divide by what? N.
The number of tests.
Exactly. So y'all know how to do that. So don't let it be confusing. There you go. And that's what they're doing. They're showing you what the frequency is, and then add up the frequency. I can be fancy. I can hold my pinky up and be fancy. 8 families had no children. 8 families had no children. 11.
That don't make no sense.
I don't. 8 families had no children. 11 families had 1 child. 18 families had children. Whatever. There won't you see a pattern. I'm just going to go to it. Note that the sum of the frequency is equal to the original number of pieces of data.
You feeling okay? You all right?
Yeah, I'm choked up. The classes would be of the same width. Okay, now we're going to talk about width. The classes should overlap and da-da-da-da-da. All right. I hope they give us an example. Okay, here we go. On the right-hand side, when you have a class, let me do this. Let's say this is classes, and then you got head count over here. Or if you're in a fancy place, a frequency. Okay? And you have your classes on the left. On the left-hand side, these guys right here, that's called the lower class limit. On the right-hand side is called the upper class limit. Now, why do you need to know that? Well, there's 2 or 3 things you get from the classes on the left-hand side. And I'm going to highlight these 2 guys. And I'm going to highlight these 2 guys. Now, if I subtract those 2, if I say 5 minus 0, what do I get? 5. If I say 9 minus 4, what do I get?
5.
5 is your midpoint. I just had a brain bubble. Is your class width. Okay? You need to know that. That's very important. That's a test question. It's also going to be important later on. Class width. So
I thought that was the way that you count up, like on the left side.
I don't teach that. I don't teach that. You know why? Because if I count from 0 to 4, a lot of people will say, okay, 4 minus 0 is 4. That's not the class width. The class width is 0, 1, 2, 3, 4. The class width is 5. I do not teach people to do 4 minus 0. I don't teach them to do that because that is not correct. I tell people to do 10 minus 5. What's 10 minus 5?
5.
What's 10 minus 15?
5.
What's 20 minus 15? What's 25 minus 20? Go vertically. What is 9 from 14? What is 14 from 19? What is 19 from 24? What is 24 from 29? All of them are 5. The class width on this is 5.
That looks easy enough.
It is, but if you try to go the other way, you're going to get confused. So I don't even show that way.
Oh, okay. Gotcha.
All right, so the first thing we learned was the class width. Class width, I'll just put a reminder that is your lower class limit of your second number minus the lower class limit of your first number, or the lower class limit or the upper class limit of your second number minus the upper class limit of your first number. In other words, go vertically. 5 minus 0 or 9 minus 4. The second most important is called the midpoint. The reason you have to have a midpoint is so you can calculate with classes. Well, what do you mean calculate with classes? Well, later on when you go into Math 120, for those that come back and do Math 120, you're going to be calculating the mean of a frequency distribution, and you have to calculate the midpoint. Now, if I wanted to multiply, let's say like I have, let's say this is how many kids you got at home or something. I don't know. Let's say ages of kids that have red hair. I don't know, something. All right, so we got 2, 5, 6, 10, 4, and 3. One of the formulas that you will learn in the future if you take Math 120 is to take the frequency and multiply it by the midpoint. Why? Because how can you multiply 2 times 0 to 4? You can't. You'd have to multiply 2 times 0, 2 times 1, 2 times 3, 2 times 4, and that's too much work. So what you do is you find the midpoint so you can calculate the midpoint times the 2 in the future.
Where did the numbers on the right come from?
I just made them up.
Okay. Just make sure I didn't miss something.
Yeah, I'm just making them up. All right. Now, how do you find the midpoint? The midpoint is equal to the upper class limit plus the lower class limit divided by 2. In other words, you're finding the average between the two. So what's 0 plus 4?
4.
4.
And 4 divided by 2?
2.
So 2 is the midpoint between 0 and 4, which you all know that 2 is between 0 and 4. Now, how do they work together? Now you can calculate each one, or what is the class width?
5.
So add the class width to each one. Okay, this is 2. So 2 plus 5 is what? 7. 7 plus 5 is what? 12. 12 plus 5 is 17. 17 plus 5 is 22. 22 plus 5 is 27. So you can actually find the midpoint of each class by just finding the first midpoint and adding the what?
Width.
Adding the class width to each midpoint. Okay? So, and if I get a chance, I'll show you how this works. Just for your information, I'll show you how it works. But right now, you need to be able to find class width and the midpoint. Let's see what else they ask you to find. Probably going to find the class boundary, but I don't know if they go into class boundary in this book. Let's see. So let's see what the next one. Okay, they don't do it. Okay, a frequency distribution of family income. The first thing you do when you want to find a frequency distribution is you have to put all the numbers in what? In order. That's the first thing you do. So write that down. All the numbers have to be put in order. What's wrong? Something wrong?
To find what?
I'm trying to make you smaller so we can see the numbers,
Oh, okay.
but it's not going to work.
You said they all have to be in order to find what?
To find anything.
Okay.
To find anything. Frequency distribution. To make a frequency distribution. What?
We just minimize you for a minute.
That's fine. I don't care.
Okay.
So look at that number list and put them in order. So go ahead and do that right now. I'll give you a minute to write them down. I'm not going to rewrite them because it'll make a mess if I do. Now, they're going to ask you to put some of them in a class. So how many are from 31.5 to 37.6? So you take your handy dandy highlighter.
2.
And we find 31.5. That's that one. And 35.5, right? Those two are between, so that's 2. And I notice they tell you to rearrange data from lowest to highest, put it in order. So 31 to 35 is what? 2. Now, go ahead and find the class width. The class width is 37.7 minus 31.5 is 6.2. Now, if I wanted to find the midpoint of each one, I'd find the midpoint of the first one, and then I'd add the 6.2 to each one. But they may not ask that. Now they went ahead and filled it out for you. They didn't expect for you to know that. They're trying to show a point how to go about, putting the data in order and then counting how many are between the lower class limit and upper class limit. And that's what they just did. It should be going to relative frequency, but I don't know if this book goes to relative frequency. I don't know if they go into depth that much, but we'll see if this slide goes to relative frequency.
Could you go back just a second, please?
Now I do want you to highlight this class right here. And I'll highlight it green. Why did I highlight that class? Anybody want to take a guess?
Because it's the middle.
It's the one, not the middle. It shows up the what? Most. Write down most and mode, modal. That is called the modal class. It's called the modal class. I'll write it in green so it'll match. Well, I'll write it in some kind of green. It's called the modal class. Modal class is the class that has the what? It has the hump. In other words, if you was to draw this a graph, it represents the hump where it goes up. Y'all got that one written down now? The chart, you got the frequency distribution.
Yeah. Yes, thank you.
Thanks.
Okay. There's the modal class. Class mark of the first class, we got that. That's the class mark of the first class. Okay, mark through that. It's not called the class mark, it's called the midpoint. The midpoint of the first class. So let's go back. Make sure you understand that. Go ahead and find the midpoint of the first class. Take your calculators and take 31.5 plus 37.6 and divide by 2. Do that with your calculator. And tell me what you get. 31.5 plus 37.6 divided by 2.
50.3.
Can't.
Hold on.
I don't think you did that right. 31.5 plus 37.6 divided by 2.
34.55.
There you go. And that's called the midpoint. So where it says the class mark through that and put midpoint. I've never seen it called class mark before. I've never heard it called that before. I've seen a lot of different books, and they've always called it the midpoint. Must be Russian. Oh man, this is.
34.57.
Okay, this is a histogram. What?
So my pencil won't quit breaking.
You got to use 0.9 lead.
Yeah.
0.5 breaks.
This is 0.7.
Yeah, they break. You get 0.9. That's what I had to use through Clemson because I kept breaking my lead. I finally found 0.9 and I kept using it. I want you to draw a picture. It doesn't have to be detailed. The main thing that you have to learn is the difference between a histogram and a bar chart. This is where I disagree with this because to me, this is absolutely ridiculous. But I'm going to show you the difference.
There are pictures of that.
4, 5, 10, 15, 20. What's the difference between the two?
The columns aren't together.
That's the only difference. You know, some people call themselves statisticians. I think they are statisticians because they couldn't get a math degree and they wanted to do statistics, so they called themselves statisticians. Sometimes I believe they make up stuff in stats to make themselves feel like a legitimate science. I don't know. But this is one of the things that I disagree with. A bar chart is a bar chart, okay? I don't read. Why have a histogram? What's the point of them touching each other versus not touching each other?
Nothing.
There's no reason for it. So I'm very critical of histograms because all they are a glorified bar chart. I hope that makes sense what I just said, but I just think it's kind of ridiculous to have two classifications of what is really a bar chart. It's kind of like justification for a job, but I'll just keep my mouth shut. So, does anybody have a question about the difference between a bar chart and a histogram? Make sure you can read it. Okay, make sure that you can say, okay, there's 1, 5, 6, 7, 8. There's 8 people in this class, and there's 11 people in this class, and there's 16, 17, 18 people in this class. That's the modal class. 2 is the modal class because it has like 23 people in it, or I'm sorry, 18. And then here is again 11, excuse me. And then here we got 6. And then here we got 4. Here we got 2, 1, 2, 1. So how many people make up the whole group? You'd have to add those numbers up. And that's why you need to know how to read it. Because a test question or a standardized test question, they're going to give you a bar chart or a histogram. They're both the same damn thing. Okay, this is 7. No, this is 8. This is 11. This is 11. We said this is 16, 17, 18. We said this is 6. This is 4. This is 2, 1, 2, 1. How many people make up the whole group? Well, there's 18 and 2. That's 20. Yeah. Okay, that's 20. There's 10. So that's 30. And then 11 and 8 is what? 19. And there's 20. So, I mean, yeah. There's 20. So we got 20, 20. And that's 50. And then what?
64, 60.
60 what?
4.
Somewhere around there. Yep. So n is equal to 64 because you added all those up. That's a test question. Not only on my test, but it's a test question on standardized tests. They'll just give you a bar chart and say, what is N? And half the people sit there and look at it and don't know. All right? Make sure you know how to read one. And as far as the difference between them, to me, that's a bunch of bull crap. If there was a mathematical purpose for them to be touching each other versus to this day, I really don't know why they even have a histogram. But that's just me. Bar charts can be written as squares, or they can be written as circles. They can be written as anything. Okay, so here's my God. There. Okay, I took the bars away and I just used dots. And what did I do with the dots?
Connected them.
Connected the dots, just like you did back in grammar school with your little pictures. You connect the dots. Same thing. This is called a line chart. Okay, write that down. It's called a line chart. Make sure you know how to read it. Make sure you can get the 0 and the, let's say there's 8 of the 0 number of children. There's 11 of one child. These are families of so many children. There's families with 2 children is 18. There's 18 families with 2 children. There's 11 families with 4 children, or 3 children, so on. Excuse me.
Bless you.
Thank you.
Bless you.
Okay. So far, and they're going to show the pie chart too. Yeah, that's going to be on there too. But stem and leaf. Okay. Notice, I want you to write down the chart here, or the numbers. Put them in order. So, if I was to put these in order, I'm just going to do it this way. I'm just going to draw a stem and leaf plot. And right here, what's my lowest number? My lowest number is 29, right?
27.
Thank you. So 20s is going to be the lowest number. 30s, 40s, 50s, 60s. What's my highest number?
72.
So there's going to be the left-hand side. Now there's 2 ways to draw a stem and leaf plot. One's called a stem and dot, one's called a stem and leaf. I don't care, okay? But with a stem and leaf, you put the numbers that are shown. How many 20s do we have? We have a 28 and a what?
27, 28, 29.
Thank you. Where's the 27?
Right there beside 50.
I said the
All right.
same thing.
So what I put over here, I put a 7, comma,
An
8,
and a 9.
and a 9. So I've got a 27, a 28, and a 29. I mark those out. Okay, 30s. Let's see what 30s. Do we have any 30s at 30? I don't see a 30, but I see a 31. So I'm going to put a 1 here. Let's see. How about a 32? No 32. Oh, there's one.
32 and 39.
32 and 39. Is that all of them?
Yes, sir.
Okay, now 40s. I already see a 43. Let's see if I see I see a 43, a 44, a 44, and a 47, and a 45. So 43, 44, 5, oh, 2 4s, 5, and 7. Y'all check me.
Yeah, that's right.
43, 44, 44, 45, 47. And then 50, I got a 50, there's a 0. And then a 58, a 56, 58, 59. That's why it's easier to put them in order. 0, 2, and 8. And 1 and what? 2. Somebody tell me which one is the modal class? 40s. 40s. 40s is the modal class. You can see the little hump. Now, what's the difference in the stem and leaf and a stem dot, or whatever they call it, dot leaf, I don't know what they call it. Instead of having 3 numbers here, I would have what? 3 dots. And then I'd have 3 dots here. And then I'd have how many here? 5 dots. So you need to make that distinction. I don't know if they're going to ask you that or not, but I'm going to take my handy dandy red marker. I'm going to put a dot here, 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 a dot here. So if they ask you for a dot, I think it's a stem and dot or whatever, I can't remember. But sometimes they do it with numbers, sometimes they do it with dots. But the main thing that you need to see is if you want to draw a curve, what would it look like? It would look like that with a hump in near the middle.
Oh, that's so weird.
Huh?
That's so weird.
What's so weird?
Do they make you draw that?
Well, that's just something that I do for students. They don't make you draw it, but they're wanting you to see it.
Oh, so they don't do that on the test?
No, they don't ask you to do that, no. I'm just trying to help you out.
Gotcha.
And there it is. Circle graphs. I told you they were going to do this. Pie graphs, pie charts. This is a test question. So far, every one of these are pretty much a test question. As far as the what is it, the bar chart or the histogram, the stem and leaf, the line graph, and the and circle graph. All these are good standardized test questions. Okay, now you got to be able to read a test question with a pie graph. That's what most of your test questions ask you on a pie graph. They'll say, if there's 1,000 animals in the zoo or in the circus, how many of them are tigers? Let's go with 100. It'll be easier. There's 100 animals in the circus. How many of them are tigers?
38.
38, because 38% of 100 is 38. 38% of 1,000 would be 380. You got to be able to take the 0.38 and multiply it by the total. What if I gave you 1,220? Then you're going to have to use your calculator. Unless you're Rain Man, you're going to have to type in 0.38 times 1,220. So if I ask you to give me, if I say that there's 500 animals in the circus. 500 animals, I can't spell today, in the circus. Then somebody tell me how many tigers are there?
190.
Thank you. You take 0.38 and multiply by 500, and you said it was what?
190.
190?
Mm-hmm. I think. Hold on. Divided or
Multiply.
That's what I did, yeah.
Well, 10% would be 50, 30% would be 150, yeah, 190.
Yeah. Okay, you're making me question myself.
I'm trying to get you to quit. All right, so tigers would be What if I said, how many, oh, not animals, I'm sorry, how many acts? Let's take that off and put acts. All right, how many jugglers are there? Well, 14.14 times 500, how many?
70.
70 jugglers. So you got to be able to do that, because on any kind of standardized test, if you see a bar chart, then I can tell you right then, you're going to, I mean, not a bar chart, a pie chart, you're going to have a question about, you know, if how many blah, blah, blahs. That's what they're going to ask you. So we've got about good 4 or 5 test questions right there, and we haven't even got to probability yet, or statistics. We're just going over basic math stuff right now. And I'm trying to get my mouse to work. Okay. What time is it? I see people outside the door. Oh, it's almost time for class. Class is over at what time?
2:10.
Okay. Okay, that's what they're doing right there. They're showing you that. Okay. We'll go ahead and finish up 12.3. We'll finish that, and 12.4 we'll go on with that. Y'all have a good day. Work on 12.1, 12.2, and also work on your autopilot too.
Okay.
And all you going to be dropped. I'm going to drop all of y'all.
All right.
Please don't.
Y'all have a good day.
See you.